All right, so thinking back to question number 9, looking at this idea here, right? So when you're looking for sound waves, what controls the energy? Well, that's the frequency. So the faster that something vibrates, the higher the pitch is, the more or the greater amount of energy that that sound will have. So if you think back to when I played those sounds in class that were really high pitched, it kind of hurt your ears. Well, it's because those sound waves have a lot of energy. All right, so if we go to number 10, draw a sound wave that has low frequency but high volume. So here I have two answers. So you could have drawn it the compressions. So here we have, looking at this idea here, low frequency, so very few compressions. So there's a compression there, compression there, compression there, but high volume. So I made sure to make a lot of space in between when those sound waves are going to spread out. Or you could have drawn it like this. We have done it like this in the past, so this is still correct too. Where you have not a lot of low frequency, aka not a lot of vibrations, but high volumes. That means the waves are going to be tall. So this is what your answer to number 10 would look like. Now, looking at number 11, a sound wave that has a high frequency but low volume. So what does that mean? That means lots of vibrations, but not very tall. Now, I tried to draw this with compressions, but I'm going to be honest, it's just really, really bad. So if you're looking at this one here, high amounts of, so it's not very loud, so there's not a lot of space in between the compressions. They're not very drawn out, but also I tried to draw a lot of compressions. There's a compression there, compression there, compression there, and it get kind of sloppy right in this space here. So either one would be fine with me, but remember frequency, vibration. So high frequency, low volume, that just means low wave height, but lots and lots of vibrations. All right, so why does sound travel faster in solids than it does in the air? Remember, sound requires a medium. So sound travels faster in solids because the molecules of solids are closer together. So since the molecules are closer, energy can transfer easier, faster. So that often produces loud noise. Like if you knock on a door, or if you put your head down on a lab table and you knock on it, it sounds really loud because the sound can transfer so much faster and easier through solids. So keeping this whole theme going. So when we listen to music, right, we're looking at treble and bass. Well, what separates the two is just frequency. It's not volume. Bass waves are low frequency, things with very few vibrations, right? Much lower than treble. Treble, high frequency. That means tons of vibrations, a lot higher pitch. Because if you look at it, bass sound waves are somewhere between 20 and 300 vibrations per second. Treble is somewhere between 4,000 and 20,000 vibrations per second. So you're looking at something that's so much greater in frequency than this what it is down here for 13. So for the second half of the study guide, this is all about light. So on this spectrum here, this talks about all of the different types of electromagnetic waves. Now, we have radio waves, microwaves, infrared, visible, ultrasound, X ray, and gamma. Well, the only ones that humans can see are visible. That's it. All these other ones, these wavelengths, our eyes can't see. Therefore, we only see visible light. So, what seems to separate one wave type from the other? Well, if you look up top here, it's the wavelength. Wavelength is what separates one wave type from the other. So, if you're looking back to 14, so remember we can only see visible light, which is made up of red, orange, yellow, green, blue, indigo, and violet. Everything else we cannot see. Now, but with 15, though, if we look here, wavelength is what actually separates one wave type from another as well. So, just using this chart alone, you can answer, or looking at just the top of the chart, you can answer 15. All right, and then here we have the higher the energy of the wave, the blank the wavelength. Well, the higher the energy, the shorter the wavelength will be. Remember, that means it's going to be vibrating a lot. Therefore, if you look here, like this wave here is vibrating a lot. The distance between the top of one wave to the top of another, not a lot. So that means it's going to be shorter. Whereas the opposite is true. The lower the energy of the wave, the longer or larger the wavelength is going to be. You could say longer, you could